Greetings, students. So I was looking at your quizzes, and there are two questions that stood out that a lot of people were missing. So I figured I will go over these two questions so you know how to do them for the future. Okay, so the first question that was fairly commonly missed is a multiple choice question. It's right here on the screen. And these are multiple choices, by the way. This is 1, 2, 3, and 4, like maybe A, B, C, D. Okay, so these are the choices. Okay, so it states that a random sample of size 15 is obtained from the population with the mean of 68 and the standard deviation of 16. What must be true regarding the distribution of the population in order to use the normal model to compute the probabilities involving the sample mean? Assuming that this condition is true, describe the sampling distribution of X bar. Okay, so we are talking about the distribution, about the population distribution, okay? And I think a lot of people said that the population must be normally distributed and the sample size must be large. So that was a very common answer, but unfortunately that answer is close, but it is not correct. So first of all, we're looking at this question, and the first thing that stands out is the fact that the sample size is 15, which does not satisfy the central limit theorem. Remember that the central limit theorem states if the sample size is greater or equal than 30, then our sampling distribution is approximately normal. Okay, so but we don't have that. Our sample size is 15. So then the only way to really get the normality in this case, to get the normal distribution of a sampling, a normal sampling distribution, is if the population is normal. So since our sample size is only 15, then population must be normal or normally distributed. We can just say normal. Okay, so then we're looking at our choices. So this A says since the sample size is large enough, the population does not need to be normal. That is incorrect. That would have been true if the sample size was 30 or greater. The sampling distribution might be assumed to be normal. There is no reason for us to assume that. So therefore, the population must be normally distributed. So this is our answer. So only if the population is normally distributed, then we can assume that our sampling distribution is also approximately normal. And that is part of the question. And I think, okay, then it also says describe the sampling distribution of X. So it's not part of the multiple choice here, but if we did want to do this, so if our population is normal, so if C is satisfied, if C is true, then sampling distribution is normal. And by the way, I think I said earlier it's approximately normal. No, if our population is normal, then the sampling distribution is also normal. But if we have to use the central limit theorem, then it is approximately normal. There is a difference there, slight difference, but it is still a difference. So if our population is normal, then the sampling distribution is normal. And one more thing that we can include here, and the spread, it is less spread. Because remember, the standard deviation of the sampling distribution is equal to the standard deviation of population divided by the square root of n. So then our spread, our standard deviation of the sampling distribution would be smaller. Okay, so that's question A. Not question A, but I think it was question number 4 on the quiz. And a lot of people were missing it. A lot of people were answering D, but C in this case is a correct answer. And now the most missed question is actually question number 8. So very few people got this one right. So I wanted to go over this. There are parts A and B, but they're done the same way. So I'm just going to do part A. So a researcher studying public opinion of proposed social security changes obtains a simple random sample of 30 adult Americans and asks them whether or not they support the proposed changes. To say that the distribution of p hat, the sample proportion of adults who respond yes, is approximately normal. So how many more adult Americans does the researcher need to sample in the following cases? So we basically want to show that our p hat distribution is approximately normal. So we have a distribution of many different sample proportions, and we want to make an assumption that this distribution is normal, but we cannot make that assumption yet. To make this assumption, we have to follow large counts condition, which is n times p hat times 1 minus p hat. It should be greater or equal than 10. So right now, so this condition is called large counts. This has to be satisfied, but right now it's not. Let's see that really quickly. So we know that our sample is 30, and in this case, we're given 15%. That's our p hat. We also can treat it actually as a p. Actually, it's not going to be p hat because I don't think it's a sample. So we use p hat if we don't know the population proportion. But here we're kind of assuming that the population, or at least as far as we know, the population proportion is 15%. So p is 0.15. Okay. So now if we perform to see if this condition is satisfied, let's see what happens. 30 times 0.15 times 1 minus 0.15. Sorry. If you calculate this whole thing, I think I've done it earlier, and if I'm not mistaken, it gives me 3.825, which is clearly not greater than 10. So right now, this condition is not satisfied. That's why the question is, how many more adults do we need to sample? So therefore, we don't know the sample size. So the sample size that we have is unknown. So n, the sample size that we took originally was not big enough. So we have this n, but then it's times 0.15 times 1 minus 0.15, and that should be greater or equal to 10. And we have to solve our inequality for this n. Okay, so let's do a little bit of algebra. So we have n times 0.15 times 0.85 should be greater or equal to 10. And then we can divide both sides by this product. Now, keep in mind, if you're dividing it, you could multiply these two numbers first and then do the division. Then just be careful about rounding. Let's see what we get in that case. 0.15 times 0.85. Okay, so let's actually do that. So if we multiply these two decimals together, we will get 0.1275. And please don't round this, because if you round this, your overall answer will be a little bit off, and that could cause you getting the wrong solution. So it's going to be n times 0.1275 greater or equal to 10. And now we have to divide both sides by 0.1275. Okay, and then this cancels, of course, and therefore we get n is greater or equal. And now let's see what we get in this case. Oops. And we get 78.43. And then there's some other decimals here. Now, that's the first thing. So here we actually had to do a little bit of algebra, one of the very few times when we actually have to do some algebra in statistics. Another big important part, whenever you are finding the sample size, you always round up to the nearest integer, even though most of you know that mathematically, if the decimal is below 5, then you round down. But notice that here we have the greater than sign. So that means we should sample 78.4 or more people. Well, we cannot sample 0.4 of a person. So therefore, we always round up. So that means that your sample size should be at least actually 78. So we're going to say, sorry, 79. We have to round up, always round up. So when we're looking for the sample size, always round up. So n will be 79 or more. Okay, but that is still not the answer, because it's a little tricky of a question, because the question is how many more do we need to sample? How many more adults do we need to sample? We already sampled 30. We already know that part. It just turns out that 30 is not enough. So how many more do we need to sample? Well, it is the remaining amount. So it's 79 minus 30 is 49. So we need to sample at least 49 more adults. So, and that would be our answer. So there are several tricky parts to this question. That might be the reason why so many people were missing it. First of all, is the whole calculation to even know which formula to use. So we have to use this formula right here, the large counts condition. That's kind of the idea. We need to know how many more adults we need to sample in order to be able to use the normal approximations. And then once we realize that this is the formula we need to use, we have to perform some algebraic calculation, which some of you might have not have done in a very long time. So we have to do this algebra piece. And after that, there's another tricky part. We need to remember to round up, which was a problem on some of the answers. And finally, the biggest, another tricky part is we're not asked how many, what should be the sample size by itself. We need to know how many more people we need to sample. So that's why we're subtracting the sample size that we need minus what we already have. Remember, 30 is what is how many people were already sampled. So it's 49 more people that needs to be sampled. Okay, so these two questions were fairly commonly missed on the quiz. So I figured I'll record a video over them, and so everyone knows how to do them. Of course, there are other mistakes on the quiz depending on your individual mistakes. So if you want me to go over any of the mistakes on your quizzes, please send me individual message, and I will record a video for you individually going over whatever you would like me to discuss. Okay, I hope this is helpful. If you have any questions at any point, please reach out and I will be happy to help. Have a good day.